talked about lines and segments. Right? Today we're going to talk about angles. So if you go upstairs and kind of draw the diagram as you go, as the directions say. A unit for measuring angles is what we call a degree. So if we say an angle is 90 degrees, you can just write 90, and the degree symbol is kind of that open circle. That looks like it's color, but it's not. That's just open circle that means degrees. A ray is basically half a point and half a line. So it would look like half a point, we'll say it's point A. And then from point A, it's going to step and have half a line. Somewhere on that line, there's going to be another point. Let's call it point B. Questions? That's a ray. And we'll get into how to name rays here in a second. Very similar to naming lines. An angle is two rays with a common endpoint, and we call that common endpoint a vertex. So what it would look like, let's say we have a ray kind of going in this direction. We'll say this is A, and this is C. There's one ray. Starting from this endpoint, there's another ray. And that would be an angle.
And sketch these pictures too, guys. So you have a reference what they look like. There's not really a spot. You got lots of room over there. Right.
There's two rays that are connected at a common endpoint, and that common endpoint is called a vertex. Hey, what's the vertex of that angle we just drew? What's that common endpoint? That sounds big. Hey, very good. There's a vertex, and you want to make a note. Okay. For sides, they're the rays that make up an angle. So if you were to, you're going to be told what are the sides of this angle, your answer is going to be two rays. How you name a ray is really similar to how you name a line or a segment. You draw a mini ray. And we're going to use that green angle above as a reference. Okay? You want to always start at the vertex. So I'm going to start at A and follow it in one direction. What's the next point? There we go, that's one side. Then you repeat the same process. You draw another mini ray. Always start at your vertex. You said the vertex is A. And then follow in the other direction. So that point you would follow to is C. Those are the sides. The vertex, again, we talked about common endpoint, and this angle, it would be A. Right there. With a right angle, what does a right angle have a degree of? 90. Good, 90. What about an acute angle? What do we know about those? They're measured as what? Less than 90. So, less than 90 degrees. Can't be 90, but smaller than 90. What about an obtuse angle? What do we know about those? Yeah, more than 90 degrees, but it's also less than 180. Very good. So it's between 90 and 180. What do we know about a straight angle? What's the measure of a straight angle? No one knows what a straight angle is?
180.
Yeah, 180. 180 degrees. If we draw diagrams of these, an angle that's 90, like this. What do we put in the corner so it represents a right angle? Oh, here's one. Little box in the corner. Acute angle is just a little baby angle.
You gotta make a little sketch to help yourself out on some of these. Especially the ones you're unsure of.
The obtuse angle, a very wide angle. What about a straight angle? A straight angle looks like. Yeah, guys are very good at the line. Just a regular old straight line. That's a straight angle. And then an angle bisector, we talked about segment bisectors yesterday. What does a segment bisector do? Cut the line in half. Okay? So what do you think an angle bisector is going to do? An angle. Angle in half. Well, if we have an angle, like so, and there's a ray or a line coming from the vertex, it's cutting that angle in half. And we show that two angles, when it's cut in half, these two little angles, what do we know about them? Cutting in half, those two little angles are now, what was 45, but they are the same, they're congruent. And to indicate that angles are congruent, we just make little arcs. So an angle, two angles have one arc, then we know they're the same. Two angles have two arcs. We know those two angles are the same. They don't have the same number of arcs, then they're not the same.
You'll see much more examples, many more examples down the road here. All right, let's move on to the next step. Talk about naming. How do we name angles? Well, there's three ways you can name various angles. One way almost works exclusively almost every single time, but there are other ways of doing this. The first way of naming angles is naming it by 3 points. 3 points. So, look over here. Now, there's something special about these 3 points we'll make mention here in a second, but I can name this angle over here. I would call this angle, and all I'm doing is draw an angle symbol. Now, give me 3 points up here that include this angle. I like the letters you said. They got to be in a specific order.
Oh,
BAC. Now, the reason why it has to be BAC is because the vertex has to be in the middle. So I make a little note right here. If you're going with 3 points, vertex must be in the middle. So ABC would not work because ABC, that would put that up here and it would make almost a triangle kind of thing. We're not working with that yet. You could call it BAC. What other thing would work if I said BAC? Is there another one that would work? Yeah, CAB, CAB. That would work too. Again, you could flip it and name it different ways. This way almost always works. You can always name an angle by 3 points. So if you're trying to name it, that always works. These next two do not always work, so be careful with this one. The next one is naming it by its vertex. So the angle where, or the point where two rays come together, two rays intersect. So looking up here, I could call this angle what? What is the vertex? A. So I could also call this angle A. This way does not always work out, because if I have more than two rays coming together, you'll see examples down the road. If I had another one coming off right there, that would not work. I don't know what angle A is. There's 4 different options it could be. So you have to be specific. But in this case, there's only 2 rays. You can call it angle A. That's the angle we're talking about. Name it by its vertex. The last one is labeling it by its number. So look in between those 2 rays. Again, there will always be in between 2 rays. Right here, right here. What number is between there? 4. So I would call this angle 4. Why they use numbers? Because sometimes there's multiple angles up there. They want you to precisely see where it's at. So they'll say that's angle 4, angle 5, angle 6, whatever it is. But that does not always work. Not always the case. Most of them don't have numbers. But if they do have numbers, you could call it that way. Questions on the 3 ways? You can do it. Again, the number 1, the 3 points is what you're going to do. Just make sure the vertex is in the middle when you name it. Because order matters with angles, as you find out down the road. Good with these? All right, so let's talk about this one. This is, again, we did a little bit yesterday with congruent versus equal in angle measures. Yeah, the other day we did it on segments. Now we're talking about angles. So we got a diagram to the right over here. This little M stands for measure. So anytime you see a little M in front of something, it stands for measure. So the measure of angle NMP is 25 degrees. NMP is 25 degrees. and the measure of RMQ is 25 degrees. So if they're both 25 degrees, what do you know about the angles? Yeah, they're going to be congruent. So I could say that this angle is congruent to that angle, because they have the same values. But, this where you notice that the angles are congruent. This is just a little technicality, you'll see it though. The angles are congruent, but their measures are equal. That's kind of weird to say, but the angles themselves, as you put them up there, they are congruent. They're the same size and shape. We'll talk more about that later, but these measures are equal. They're the same. And they just represent, you see the difference. Congruent, we're not talking about measure. We're talking about them being exactly the same. The measures over here are equal. It's going to help us solve coming up problems. We'll do more practice of that. Don't worry about it right now. All right, this one right here. So let's do some examples of how we do this. And again, there's more than one answer for a lot of these. So, looking over there, number one, name the vertex of angle 2. We always recommend if you have highlighters or colored pencils, shade it in. If all else fails, just trace it out. Angle 2 is right here. It's always in between two rays. So where do those two rays come together? That would be your vertex. So where do those two come together? M. So guess what? My vertex is going to be point M. Point M. Or just dot M. That's my vertex. So they come together. Number 2, I went out of order, I just realized. Number 2 is over there. Name the sides of angle 1. Again, outlining. I love outlining, helps me visualize a lot of these things. Sometimes they're hard to see. So there's angle 1 right there. The two sides, it's two rays together. Well, name the sides. Well, when I'm talking angles, what is an angle? And when I have that, I just kind of gave it away. These are rays. All right. Well, can someone name me those rays? Name me the sides. Give me one of the sides. There, Megan. J what? J, and there's 2 points for a ray. Okay? That's part of it. Yep, I'll say. I just want to know if I wanted to name, let's say, this side right here. How would you call that side? It'd be what? It'd be 2 points. JM, I like those. All right? She's saying J and M. Now, we said with rays, you got to know which way it's starting. There's got to be a point. Remember, it's a kind of a blend between a segment and a line where you have one end and one goes on forever. Where does it stop? Where's the ending point? It stops at M, right? And it keeps going on forever, J. So I like to have those first, MJ, and I just have that arrow above. So starting at M is going at J. That's what it is. I'm going to write that again because that arrow is not very pretty. There we go. MJ. Michael Jordan. Well, if MJ is one side, what's the other side going to be? MK. What?
Michael Kors.
Okay.
Michael Jackson.
Well, MK. Well, we could go with that too. MK, the letter goes the other way. Could you flip it around if I were to say JM, like you originally said? Yeah. Just make sure arrow's pointing the other way. But usually we like them going to the right. But potato, schmonato. Number 3. Name 2 other names for angle 1. Well, let's highlight. Angle 1's already highlighted. Who can name this 2 other ways? It's already called angle 1, so we can't use the number. What do you think? Can I? Vertex M would be a great answer. But no. And a lot of people want to say that. I'll say why. It looks like that is where it comes together, correct? I agree. It does. The vertex is M. So you can say angle M. We can't do that for this reason. You can only do that when there's 2 rays coming together. Because also over here, oh, my voice cracked, angle 2. What is angle 2 vertex? M as well. They have the same vertex, but they're not the same angle. Not only that, what about JML? What vertex is there too? M. All 3 of them share the same vertex. So I don't know if you say angle M, I don't know if you're talking about the green one, I don't know if you're talking about the blue one, I don't know if you're talking about the red one.
But what if we say JMK?
If we said that is good. I like that explanation. She said they do share M, but because you said those 3 points, she said JMK. It's just correct. Well, I don't know if that color. If I said JMK, angle JMK, you're telling me a specific order to go. When you say go to J, go to M, go to K. JMK. That's angle 1. That is correct. That's specifically telling me where to go. If you would have said JML, that's the whole thing. If you would have said KML, it's the different one. Now, what's the other way of naming this? Like this? What do you say? Angle 1? Yeah, it says angle 1, but yes, I would agree with that. It said angle 1. It's already agreeing there. That is another way. I might even accept that and put that on there. What can I do with these letters to name it a different way? Yeah, flip the letters. So I could also call this angle KMJ. Works for me. There. You can always flip the letter. Just make sure the vertex, which we said was M, is in the middle. All right, give it a flip. Oh, construction. This moment of time in the program, please get out your compass, a straight edge. If you do not have one, you will need one for tomorrow. Myers has them. It's my one, right? Got a nice little pack of Meyer pack. I like that one. It's a good one. Nice that you guys got orange and black. Delaware Hayes. Go Pacers. All right. So we're going to do a first construction. You guys have that out ready to go. If not, you will need that because there may or may not be a skills quiz tomorrow. I don't know. I don't know for sure. But there may or may not be one. Okay, make sure you have that out. All right. Well, what do? Construct an angle with the same measure of a given angle. Really what I'm doing is I'm copying an angle. How do I copy an angle? Well, I know what someone's going to try to do with your fancy things. You have a protractor in there. Some of you guys might try to copy it, do that. Again, the marks show us what to do. So anytime I'm copying something, you're usually going to start out with a line. So what I'm going to do is just randomly beside there, you guys just draw a straight line. So take your straight edge, draw a straight line. Doesn't matter how long, just draw a straight line beside there. It's crooked, I don't care if it's crooked or straight, however you want to look, but it's a straight line. You can have a diagonal, anything you want. Draw that. What I'm trying to do, and especially when I'm trying to do this, I'm going to take whatever's over here, I'm going to make it over there. So what I do to one side, I'm going to do to the other. That's how you make these constructions. Go to the original one, whatever you do to the original one, copy that on your new one you're making. So I'm going to get my fancy schmancy compass. Again, I've only ever done it without doing that. All right, so I got that. I'm going to change my color to orange. Go Pacers. Go over here. So, how do I copy this angle? Again, what I do here, I do over there. This line is going to represent this line. However you want to think about it. So what I do is this. Take my compass. Put the point on the vertex. There it is. Right there on the vertex. I want you to open the compass. And again, it doesn't really matter where you open the compass. I go about a third of the way, a quarter of the way, it doesn't matter. And I'm going to make an arc that connects both rays. So it connects this bottom ray and the top ray. All right. Doesn't matter where it's at, it's nice and neat. Put it right there. And when I'm copying something, whatever I do to one, I do to the other. So I'm going to go over there, I'm going to kind of make that same arc. Yes, I don't know how long that arc is, so I'm going to kind of guesstimate here. Okay, perfect. So I'm going to make that arc very similar. Not the same size. I don't know for sure, but just look the same size. Just made that arc. I don't know where it is. I'm trying to figure out where this line is right here. And I know it's somewhere over here, but I don't know where. Next step is very easy. So I measure my arc, put it there, put it over there. Now, I want to measure the distance. So I want to measure the distance. There we go. Okay, so what I'm going to do is take my compass, put that endpoint right there again, where it was a second ago, and I want to measure how wide that opening is. So where's that other intersection? Say right there. Pretty good. I open it between the arcs. See how wide the arc is? I measured that. I'm going to make a mark. And that's my way of saying, yes, I measured. You can see it right there. I made my little intersection where they are. Did not adjust my compass. If I did it over here on my point there, made the arc, go over there to the same arc. Go to that intersection of that. I'm going to make my intersection. Now, some of you may have come across that say they don't intersect. They don't cross like they do in your picture. It's because you didn't do your first line long enough or your second line long enough. So all you gotta do is just make your arc a little bigger. If that's the case, go back here, measure this opening again, whatever you had, and then just move it back over here and make that a little longer. That's all you gotta do. So now I have that intersection, I have that. Take your straight edge, connect your vertice through that point. And you just copy that angle. There are only two things to do for a copying angle. Make an arc that connects both rays. Copy it over here. Find the distance, mark. Find the distance, mark. Vertice to the ray. Go with that one. And again, these are all online, so if you guys don't know how to do it right now, you can get on Canvas and watch a little video how to do all these. All right? And we're recording this live, so you guys can listen to our beautiful voice when we do this. All right, ready, set, next one. Now. Yep, that's what the red light means. We're live. So right here, number 2, construct an angle bisector. Yesterday we talked about if you're going to learn one construction, you should learn how to do a segment bisector. That is the most important one, and you will use about 80% of constructions who use that method. This is number 2. This is another one you use a lot. And it is very easy because all you do is make one adjustment on your compass and you can do it. So, bisect it. What does an angle bisector do essentially? What am I doing to this angle? What do you say? Split in half. I'm cutting it. He's making 2 angles out of 1. Cutting it in half. Here's how easy this one is. I got my go face for stuff. Just like before when we did copy and angle, put your point on the vertice. So where the 2 rays that come together, that's it. Again, very similar to copying that angle. Open the compass. It doesn't really matter. But I'm going to say about 1/3 or halfway. That's good for me. Make an arc that connects both. Right there, right there. So far, it's exactly like copying an angle. So I made an arc that connects both. Here's where it gets different. Do not adjust your compass. If you did, go back and remeasure it, but you don't have to adjust your compass. All I'm going to do now is take my needle and put it on those intersection points and make a new arc in between the rays. So I'm going to take it, put it on this intersection point, and I'm going to make an arc in between these rays. You don't need to go outside or anywhere else. I'm on that vertice, or I'm on that intersection, make an arc. Then I'm going to go north of the border up here and put it on that vertice. If it's not in the middle, that's fine. It's going to intersect. Once you see the next mark, it will. Then the next one, connect it. And they should come together. So once you do your other one, it will. Yep, there you go. Come down a little bit. And they'll intersect in the middle right there. Last step, vertice to intersection point. Oh. And you just made an angle bisector. Now I know that this angle is congruent to this angle. They're the same. Measures are. Again, all I did, took my compass, made an arc that connected both rays, up here and down there. Moved my compass to that intersection point, made an arc. Went to the one above, made an arc. They should intersection in the middle, and I connect my vertice to that point. And a lot of constructions aren't very hard. Most of them are less than 5 steps. You want to get crazy? I'll show you how to do a pentagon. Got like 20 steps. Not much fun. I forget a lot of the steps too, so I might draw a weird shape. Yes? All right, I will come back here in a second. When Ms. Baker is around, we'll do too. One of us will be there and will assist. Alrighty, let's look at the next one. Any questions other than that? Other than help? Again, we'll have time. We'll come around and help you at the end if need be. Alright, this next one. Let's do our first little geometric properties with it based on what we just found out. So, in the figure, ray QT. Get it? QT? That's a text lingo. You guys know that, right? Cutie? Say he's a cutie. That's what you guys. I'm on your hip language. So QT bisects angle RQS. So RQS right there. Cuts it in half. Fantastic. So what do I know if it cuts it in half? What do I know about each of the measures? They're good. They're congruent, and their measures are equal. So let's see what here. If measure of angle QST, when I switch it, it's an SQT. This is SQT, a little typo here. SQT is equal to TQR. TQR. All right? Well, so we know that. We already established that these are congruent. You said the measures are the same. Fantastic. How is that going to help me solve? Well, this is something you will see a lot in geometry, so sit down, get ready for this. I have some information over here. I know that angle SQT is that, and I know TQR is that. I've got some information, and I've got a picture. What do you think would help me solve that? Help me visually solve it. Well, help me visually set it up so I can solve it. Set them equal to each other. That's exactly right. What I would like to do, and I'll tell you this all the time, is if I have information and I have a picture, let's label that picture. Because that might make you, because you're like, I don't know what to do here. I'm looking, I don't understand. So let's label our picture, and that might make sense a little bit more. So I'm going to say this. I'm going to say this is 6x plus 5. And this one over here is 7x minus dose. All right. So I label those values. Oh, okay, now it's piecing together. I know that this QT is a bisector. And bisector means it cuts in half. And I know that each of the halves are the same. So these are both congruent. Aren't their measures going to be equal to one another? Yes, they will. So now I can say that, and I know that. I can say that 6x plus 5 is equal to 7x minus 2. That's minus. Awesome. And this just turns into a little bear problem we're going to try to solve. Different ways to solve it. Well, let's go through and give it a go. What do you want to move first? What we like to tell you is move the smaller x, just to help yourself be positive. Sometimes you lose track of your negatives, positives. So let's move the smaller x. That happens to be the 6x. Minus, minus, equal. 5 is equal to x minus 2. Baby bear problem, one stepper. What do? Add dose. Add 2, here you go. So x is equal to 7. Awesome. Right? Okay, moving on to the next problem. Right? Make sure your head no. I finished, I got x, good. Moving on to x. No, so you have to flip over, good. Good, flip over. You're wrong. Are we done? I said flip over, so you better listen to me and say you're done. There's something over there. Crazy. No, we're not done. Does it say find x?
Oh.
Does it say find x? Find SQR. SQR, well, if I outline SQR, where's SQR? It's the whole man of jam. You can't even see that. It's the whole thing right there. So we got to find the whole thing. How do I do that? That's a great idea, add together, but I don't know what their values are. That's a great way to add them together. Plug x back in. So I got to take this guy, and plug it in. It doesn't matter which one, I got to plug it in. So I plug 7 into there where the x is. So it's no longer an x, it will become 6 times 7 plus 5. So what am I going to get for that value? 6 times 7, how much we got? 47 is correct, the moon day. All right. You guys plug it in for this one yet? Who plugged it in? You plugged it in. Did you? What'd you get?
47.
I didn't have to plug it in. You know why? Oh, okay, you are. Good try. Yeah, again, it's a great way to check yourself because you got a different number, you're wrong. So this is also 47. So they're both 47. So great. And I like what Kanai just said. I want to find the whole angle. What do I need to do? Add them together. So the measure of angle, what do we call it? SQR is equal to 47, 47, 490, 94. Now, I have my answer. Now I can flip over. Now you can flip over. Drew this earlier today. What do you guys think? This picture.
Looks good.
You like it? What is it? It is not an elephant. Good try. You gotta try. This is a white horse in a snowstorm. I'll sign it so you guys know what it looks like. But yeah, that's my signature. Good. You know, I was finished number